Hi everybody, can you believe we're already at the end of the chapter? The last two learning targets. This is Mrs. Ogier
and Ms. Perrier,
and we're going to get started. So why do we want to know about density and mass? Like, what's the purpose of these two words and how it relates to things? So volume is simply the amount of space inside of something. Now, the weight of it, or the mass, will depend on the items that go in there. So for instance, if I have air in this suitcase, well, that's pretty light, no problem. But if I fill it with clothes, it's going to be a little bit heavier. If I fill it with a bunch of textbooks, good luck carrying that thing. So mass is the weight. Density is the weight of something per the amount of volume that you have. So that's why we have all of these words happening at once and why we talk about them all.
Okay, so for this one, you see it's a word problem here, so we're just going to take pieces out of the word problem to figure out our answer. So it says Norris threw a plastic toy in the tub for her dog. So you see the tub and you see the dog on your screen. It says, but there's a problem. The puppy does not like putting his face in the water, probably like your dogs as well. If the weight of the toy is more than 350 grams, it will sink. So it says we have the density and the volume of the toy respectfully of those two numbers. It says, will the toy sink or float? So we need to figure out first what the mass is. So all we're going to do is rearrange our density formula so it has mass equals density times volume and multiply those two numbers together. So as you can see, we have grams over milliliters, and then we have just milliliters. So as you can see, they are diagonal from one another, so that means they cancel out here. So multiplying those two numbers, we have 305 grams approximately, so that is less than 350 grams, therefore it will float.
All right, moving on to another example. Mary purchased a new drawing box. The height, width, and length of it are respectively 12, 6, and 3 centimeters. She wants to fill the box with pencils. The density of a pencil is let's go with 300 pencils per centimeters cubed. How many total pencils can she fit in the box? So we have to start with figuring out the volume. So because this is a rectangular prism, I'm going to do area of the base, which is 12 times 6, times the height, which is 3. And also by now you've caught on that with a rectangular prism, it's the same as length times width times height if you want to think of it like that. So that's 216 centimeters cubed. Notice my centimeters cubed match the units in my density statement. So it says the density of a pencil is 300 pencils per cubic centimeter. That's a good thing. We always want those things to match. So now from here, I'm simply going to multiply, again, the volume and the density to get the mass. In this case, it's not mass as in weight, it's mass as in kind of like size, what can fit. So 6.48 pencils, which means only 6 pencils can fit because I'm not going to, cut a pencil in almost half and put it in there. So 6 pencils can fit total.
Okay. So for this one, we have the density of the white oak tree is 752 kilograms per cubic meter. If the trunk of the tree has a circumference of 450 centimeters and a height of the trunk is 8 meters, what is the approximate number of kilograms in the trunk? So make sure here that you have centimeters that you're working with and you have meters. So at some point you're going to have to convert here. So as you can see, there's a cylinder is our tree trunk. So we have to figure out the height, which is 8. And we also have the circumference here. So when we figure out our formula, we need some sort of radius here. So to figure that out, we're going to find the diameter using the circumference formula seen. So when you figure out the diameter, you get 143.2394, all that. And then the radius is just cut that in half, which we have 71.619, all that. But that is in centimeters. We have to change that into meters. So we're going to change it from centimeters to meters, having it be 0.716, all that there. Now you have your radius and your height, plug that into the formula, and your volume of that cylinder trunk should be 12.891 whatever.
Now if you're wondering how we switch centimeters to meters, you're expected to know that there are 100 centimeters in a meter. Like there are certain things that you are expected to know. There's a reference sheet that will help you with other conversions that you're not expected to know. So that if we continue with that problem, we have the 752 kilograms per meters cubed that was given to us back at the beginning of the problem, that density statement. So we multiply that through, and you end up with your mass.
So for this one, we have a candle maker is going to have a silicone mold made from a new cone-shaped candle. The mold is created by removing a cone from a cylinder, seen as your picture. It says the diameter of the cylinder is 12 centimeters and the height is 4 centimeters. Silicone has density of that lovely number there, and it costs $50 per pound. What would the price of the mold be? So in the end, we need to figure out price. That's our end goal here. So we have the diameter being 12 and the height being 14. So what we're going to do is find the volume of both the cylinder and the cone and subtract them. So we can see that the radius is half of 12, which is 6, times our height, 14. And we'll do the same exact thing for the cone as well. And then we're going to leave it in terms of pi and then subtract those. That's our volume here that we're going to use.
Now mass equals density times volume. So again, we're going to use that density statement because we calculated our volume in centimeters cubed. It means those lovely centimeters cubed will cancel out, which should always happen when multiplying density times volume, leaving us with a gram value. Now it costs $50 per pound, so now we have to do some conversions. You are given this chart on your reference sheet, so I need to figure out a way to get grams into pounds. And if you start looking here, you'll see that I have kilograms to pounds, but not grams. You are expected to know that there are 1,000 grams in 1 kilogram. So we're going to get to kilograms, which will then get us to pounds. So if I have grams and I wanted to get to kilograms, I do that conversion like I just said. I know that there's 1,000 in there, and then I'm going to go ahead and multiply that to get the kilograms to cancel. Now, as far as the conversions go, we will spend time in class making sure everyone is comfortable with the conversions, but these are things you should be familiar with. But this is the process that you want to put in your notes. It is okay if you are super confident with the conversion that just occurred. We will practice, but you want to make sure that you have the steps down at least in your notes for now. So we end up with 5.2 and all that change pounds. And in this case, that would be multiplied by the cost of $50 per pound, giving you a grand total that you would round to the nearest cent because it's money, of $270.50. So that's it for this video. Again, make sure you have the process in your notes because that's the most important thing, is understanding the process of these. We can work on the individual parts later. Have a good day.